These processes are huge. We're talking huge areas, giant chunks of rock, and that leads to lots of problems. Right? What you're looking at in the background there is the aftermath of the Loma Prieta earthquake that occurred in San Francisco. It actually occurred during a World Series game that the Oakland A's ended up winning. But this happened at 5 p.m. in the evening. Many people died. And as you can see, lots of damage. Most earthquakes are actually imperceptible. They're happening all the time. These plates are always moving, especially on places like the San Andreas Fault. But sometimes these earthquakes can build up lots of pressure and cause lots of damage. That Loma Prieta earthquake in 1989, for example, 63 deaths, 3,800 injuries, and $6 billion in damage. But that kind of pales in comparison to the Tohoku earthquake that I mentioned that caused that giant tsunami in 2011 that destroyed the nuclear reactor in Japan. There were roughly 16,000 deaths, and this death toll is probably still increasing because there are many people that were never found, and due to potential radiation associated with the reactor, there may still be a death toll rising. There's also 6,200 injuries and almost $200 billion in damage. Right? So earthquakes can be extremely destructive. Let's zoom in on California here. This image on the left is actually the San Andreas Fault. You can go out and see it in all its glory in the Carrizo Plain. It's very easy to see there because it's flat, and then kind of cutting through the middle of the Carrizo Plain is this kind of little low rolling hills, and that is the San Andreas Fault. But that's not the only fault. Last year, I think it was, there was a big earthquake along the Garlock Fault here, basically at the junction of the Owens Valley Fault in a town called Ridgecrest. That caused lots of damage. There's all these other little tiny faults where little plates are kind of piled up against the edge of the Pacific and North American plate. Here, though, you can see the San Andreas Fault. The Carrizo Plain is right here. Right, so you can go out and see the San Andreas Fault very easily there. How do we mitigate damage against earthquakes? Pretty hard, right? There's a lot of things happening that are well beyond our control. Well, we can't do everything, but there are a few things. One thing that Japan is really good at is building earthquake-resistant buildings. Basically, the building is constructed on a pad that has the ability to flex and sway with an earthquake. So the ground moves, but the building actually absorbs most of that movement. Right? We'll talk more about some of these ways to mitigate damage here in a second, but I want to go and get to volcanoes, which is another type of geological hazard. And this is obviously still related to tectonic plates. What you're looking at here is Mount St. Helens. This is Mount St. Helens before it erupted in 1980. Here is it after. It literally blew its top. This is one of the most destructive and powerful volcanic eruptions that we've seen, especially in the lifetime of humans. There's obviously been lots of other volcanic eruptions, such as Mount Vesuvius, Krakatoa, Mount Pinatubo, but this one, it really displays the power of these volcanoes just through the sheer destruction of the volcano itself. And they don't just affect local climates and local living situations. They can be global in their destruction. Mount Krakatoa in Indonesia affected weather for nearly 5 years after it erupted in 1883. People could hear the eruption over 5,000 kilometers away. Mount Pinatubo in the Philippines lowered global temperature for 0.5 degrees Celsius in 1991. That's a lot to lower an entire planet's temperature, right? Basically, it did that by spewing ash into the atmosphere and blocking sunlight. There's ways to mitigate volcanic damage, just like there's ways to mitigate earthquake damage. one, don't build too close to them, but also testing, making sure we are able to predict and cast out early warnings when we know that a volcanic eruption is going to occur. Once again, zooming back in on California, there's a large volcanically active region in Mammoth Lakes, or Mammoth Lakes area. We call this the Long Valley Caldera. This caldera is the remnant of an ancient earthquake. The last time it erupted, it spewed ash all the way to Kansas. It's a long way away. And there's lots of geothermally active places in that caldera still. There's lots of hot springs, there's a geothermal plant, and there's lots of evidence of the volcanism. There's a really cool volcanic formation in, well, it's down here actually, in Lake Crowley, where you can see these cool columns that had formed through the geothermal activity as a result of this volcanism. Additionally, I mentioned the Cascade Range, and this is a series of volcanic peaks. In California, the two major peaks are Mount Lassen, that's Mount Lassen here, and this is Mount Shasta. Volcanic peaks are pretty obvious because they have that very typical cone shape, right? Sutter Buttes are also part of that same volcanic chain, but they're so distinct in their ecology and they're isolated that they're typically not considered part of the Cascade Range. Mount Hood, Rainier, Mount St Helens, these are also all part of the Cascades. Another geological hazard, and this is associated with volcanism as well, is landslides. And this is often caused through a process of mass wasting. More or less, soil becomes destabilized and large chunks of earth begin falling down slope. So this can be caused by a number of different factors, but humans often destabilize soil through agriculture, building, channelizing water, building roads, all kinds of things. Deforestation, obviously a big one, especially in mountainous regions. There's not a lot of agriculture happening there. Deforestation is a big cause. What this often leads to is a lahar. This is what you're seeing here. This is a giant mudslide that occurred when this mountain, as it erupted, heated the snow, melted it, obviously. That mixed with the mud underneath of it, destabilized the entire mountainside, and it flowed downhill and basically buried a town. And these happen quite often with volcanic eruptions. How can we mitigate damage, though? I mentioned a few ways. The first one was improved engineering, right? Designing buildings that are able to withstand these big eruptions and earthquakes. Testing and modeling for future quakes and eruptions is also really important, but it's really hard to predict these sorts of events. It's not like weather, right? The risks are much higher, and the factors involved are much more complicated. One way, though, is conserving habitat that protects shoreline, because a lot of earthquakes are going to produce tsunamis, and mangroves and reefs actually absorb a lot of the initial tsunami wave. Furthermore, wetlands are really good. They're going to absorb a lot of that seawater as well. Mitigating damage from landslides, a good way to do that is better forestry and agricultural practices. Soil conservation districts have been erected just for this purpose, to make sure we maintain the soil and increase the longevity of that farmland. Finally, and the most obviously, just don't develop areas prone to natural disasters. One of your readings this week is about a potential for the large earthquake to occur in the Pacific Northwest, and how a lot of people are not allowed to build anymore in an area that is most likely going to be underwater after an earthquake produces a tsunami off the coast of Washington and Oregon. So that's one of the most obvious ways to do that. All right, that's it for this week. Make sure you get the lecture review done, and I'll talk to everyone later.